we had a look at this shape, right? We divide it up into geometric figures, mostly polygons. Simpson's rule does the same thing, but he does it so much smarter. He takes this idea. This shape here has a name. Does anyone recognize it? It's called a parabola, right? We referred to this as a parabola going around the circumference of this thing. Okay. So this has an equation, y equals x squared. Okay. That's what gives it the parabolic shape. Okay. Now, what we can do is, instead of using these figures, which are all pretty blunt instruments, right? What we can do is we can take this shape and we can approximate it with a series of parabolas. A parabola like this, along with one like this, and one like this. And we can join together a curvy kind of area, something like that, this weird irregular shape, using a series of parabolas, right? Simpson's rule, it comes out as a formula. It looks like this, okay? Area is approximately equal to. So get this down with me, and then I'll show you how it works. Okay? H on 3 times, I'll call this x1. Okay, so here's the formula, and let me explain it to you. Okay? What we're going to do is we're going to divide this area up, not in this kind of fashion, but in a more regular way. Let me give you an example. I've already done this.
This is confusing my little...
Okay. Whoops, that's not what I wanted to
That is no one gets it.
Okay, so the first thing we're going to do, and actually I will ask you now to help me refocus. Would you do that? Would you refocus? Make sure it can see there. Okay. Alright, so focus on the screen so you can see. Make sure it's, if I go down, that's fine. So what I've done here is I've got my irregular area and I've sliced all the way across it. It's kind of like a diagonal, like for a rectangle, but I could draw a whole bunch of other lines. I could draw from here to here, and I would also get a diagonal. It's an irregular shape, so it's not going to follow the same rules as our normal shapes. And then, across this diagonal, I'm going to divide up the area into a bunch of perpendiculars. Like this. Here's an example. I'll pick this one. Alright, can you see what I've done? You see what I've done?
Yeah.
So what I've got here is a series of lines that run perpendicular to my diagonal. Okay? I need to know what, number one, all of these sections are. Right? So those are my H's. H stands for height. Okay, H for height, so you can pop it down on there, right? And then I've got all of these perpendicular values. They are all of the x values. x1, x2, x3. Okay? So, suppose I'm going to give you a simplified version of this shape. Okay?
Wow.
Okay, there you go. Right? Now what I've got is, let's put a couple of extra values there. What I've got is, I've divided this up. I need to make this a bit longer. Boys, this is your time and it's my time. And I'm not keen to waste it.
The drawing was like... Did you take it off, that drawing?
I just drew a whole new thing.
Oh.
So, here's what I'm going to do. The H's are these distances. Can you see they're all roughly the same? Okay? So they're the height of each of these sections. Okay? And then what I've got is these distances here that run perpendicular to the diagonal. x1, x2, x3. Okay? Now either with a trundle wheel or with the scale that you've already been provided at an aerial view, I'm going to have to measure what these distances are, and then I'm going to feed them into this formula. Okay? So let me give you an example. Let's just estimate. Okay? How far? You've got a scale down here. That's 10 meters apparently. How far do you think this is? What would you guess? Just have a look at it. Roughly. 30? 20? 35? Let's call 30 because it's an easy number. It might be somewhere you can do it more precisely. So I'm going to have 30 on 3. 30 on 3. I'm going to ask you to help me do a bit more estimation, right? This is going to be a bit longer, right? What do you reckon you want to call it? 100? It's probably a bit much, I think. Like it's about, I'd say maybe 50. We're pretty close. Again, all of this is things that you're going to have a look at in more detail. So there's the first measurement. Okay. Okay, this next one in here. This is longer, right? What do you reckon? 70? 70? I'm going to call 70. So we're measuring these lines that run perpendicular, these guys, that run perpendicular to the diagonal. Okay? Now, I'm going to do just one more. Just one more. This one here. Okay, if I wanted to keep going, I could add on more values, right? This one seems to be the longest of the lot. 90? 100? Let's just go to 100, right? Now, again, you're going to get some actual numbers for these, right? Now, I'm actually just going to evaluate. Now, these are really easy numbers, so we don't even need a calculator for most of this, I reckon. 30 on 3? 10?
Yes.
50 plus 4 times 70 is 280. 280 plus 150, that sounds like 430. 430.
Boom! My maths is it's actually 1.
So we're looking at 4,300 square meters. Does that sound right?
Yeah.
That's a really big number, isn't it?
Yeah.
Does it sound reasonable?
Nah.
I'll come back from the top, right?
Sounds way too big.
Here's our formula. By the way, just saying, if any of you go ahead and you choose 2-unit or 3-unit maths or above, right? This formula actually gets proved. We show you how a parabola gives you that. But for now, we don't need that. We just need to work out the numbers, okay? You can pop this into a spreadsheet. I can show you how in a second. And in this next line here, we're just estimating these distances based on our eye and this scale that's provided to us. You can go in way more detail by actually doing the pixels because you've got the map there. You've got the map. And then we simply substitute it. What were these heights? We estimated about 30 meters. What were these perpendicular distances? And that's where these numbers come from. We punched it in, that's what we got. Okay? Now, keep in mind, I only went this far. It's not the whole thing, right? That's only this middle section. So if I wanted to do the whole thing, I'd use more values, okay? But Simpson's rule will do it with more precision than just doing rectangle here, semicircle there, all those kinds of things.